Right, I'm just going to do this question for you like you asked me to, so just stop it whenever you think you know what you're doing and then just do it on your own, okay? Right, so we've got a £2 coin with a diameter of 28mm and a mass of 12 grams. Now that's here. This is your coin. It's placed face down on the rod with part of its curved edge directly above A. Right, so looking at this coin here, I can't say the word coin properly. Looking at this coin here, its mass is going to be in the centre of the coin, right? It's got a mass of 12 grams. So what I'm thinking now is, do we need to convert that into kilograms, or should we leave everything in grams? Okay, the fixed load also has a mass of m grams, so I'm going to leave it in grams. Right, so I've got 12 grams coming down here, and I need to times that by 9.8. by gravity, and I've also got my mass here, and I'm going to times that by 9.8 as well. Right, a uniform rod, right, so it's the weight is evenly distributed all the way along, has a length of 160mm and a fixed load of mass m grams. Right, do we know the weight of the rod? So we've got the rod, the weight of the rod here acting down, which actually it's going to turn out that doesn't matter, I think, and it's resting on this pivot point here, so we've got a reaction force coming up there as well. Right, so it's resting on the midpoint. That's also where the mass of the rod is acting, so we can ignore that mass of that rod for now. Right, a £2 coin is placed face down, blah, blah, blah. The fixed load is hung by an inextensible string, so it's not stretchy, from a point directly below B. Right, so this rod is 160mm long, so this distance here is 80mm, and this distance from the centre of that coin there to there, the coin is 28mm, so that bit's 14, so this bit has got to be 66mm, because all of this has got to add up to 160mm. So 14 add 66 should add up to 80. I think it does. Right. Okay, right. Given that the rod is horizontal and rests in equilibrium, so up equals down, find m. So if we take moments now about that point there at the middle of that pivot, so let's call that, what should we call that? Should we call that C? So if we take moments about that centre of that rod there, so we're going to take moments. If we're holding it there, if we hold it here, this is going this way and this is going this way. Right, we can ignore R and we can ignore the mass of the rod because they are at that point there, so the perpendicular distance is 0. Right, so we've got 12 times 9.8 times 66mm, and that must be equal to m times 9.8 times 80mm. Okay, so I have force times the perpendicular distance. So these will cancel. So your m is just 12 times 66 divided by 80, whatever that is. Okay, well hopefully that will help you with the rest of the question now. If it doesn't, give me a shout and I'll do the rest for you. Toodaloo!